Hi everyone.
Hey everyone.
Joining us today is Dr. Chris Dorsey, professor at Northeast University's College of Engineering.
Speaking with us today is Professor Tim Chen in the Department of Mechanical Engineering at the University of Houston.
So when I first started to do engineering research, I was asking a lot of questions related to how we design and build really, really small sensors called micro electromechanical sensors. You might know them as MEMS. And I was working in the applications of navigation and timing. So I was really interested in answering questions, asking and answering questions related to things like how you design the accelerometer and other systems in your phone, for example, that help you know where you are, to use something like Google Maps, where it gives you the little blue dot to say you're here on this street in front of this building. That's a combination of GPS data as well as things like accelerometers that can tell how fast you're going if you're turning, things like that.
Hero 6, which inspired me a lot. It's kind of dark at this moment, but you can see the idea of forming structures from elemental particles and having these structures reconfigure themselves again and again to achieve different mechanical properties. So whether if you want a material to be stiffer or softer, what if you can have one material that intelligently can be programmed to do all of these things? Wouldn't that be great? Instead of having, like you have concrete, and it's always going to be concrete, right? And concrete, as you know, is pretty hard to recycle, especially reinforced concrete, because you have to take the steel out of it and then you have to process the concrete. And the making of cement is extremely energy intensive because you have to heat this material to a very high temperature, etc., etc. So wouldn't it be nice if we can have material that can be readapted for different purposes?
I have always been really interested in how things work. I am one of those people that likes to take things apart and likes puzzles. And so the different aspects of engineering where you're trying to solve this mystery. Why does this work? Or why doesn't this work? Or how do we make it work better? Or how do we design something new? I really liked those questions. And specifically with electrical engineering, I always found it kind of really cool and mysterious how we do things like apply a voltage or apply a current, and can use those ideas to do everything from making your computer work to sending radio signals through the air so that we can talk to each other. All of those are sort of electrical and computer engineering based questions. And I just really found that fascinating when I was learning about different types of engineering.
I thought it was really cool to be able to exhibit some sort of very funky properties that you cannot get, right? Because, well, for the first question, we need material to make any engineering things. And typically we start by selecting the material as an engineer, right? You get a booklet almost, and you select the material you need, whether it's steel, whether it's concrete or wood or any material, right? You source this from nature. Wouldn't it be great if we have, instead of being dictated by the material choice, what if we can say, this is the property we want, let's make a material that gets us that property.